Okay, so why is zero intensity observed today? So understand that whenever you see these double slit patterns, you're seeing, if you had just one slit, you'd see this pattern that's like this, right? Whoa, and then it's like that, right? This is the single slit pattern, right? Okay, in the single slit pattern, we know that this distance here, that sine theta is just lambda over d, which is d is the width of the slit, which ultimately we're going to figure out, right? Okay, so this is basically the envelope of the single slit diffraction pattern has a destructive interference there, right? And that you're seeing both things. So try to make two marks out of that, right? Okay. Then it says the distance from the center of the pattern to A is 4.1. So they're saying that this distance, I'm going to exaggerate this distance, is 0.041 meters, right? And so they want us to calculate the width of each slit. We can do this. Okay, what we're going to do is we're going to use this equation here. We know that lambda is 590 times 10 to the minus ninth, right? We're trying to solve for that, and if we had this angle, right, for that, then we could do it, right? So let's find that angle. There we go. Imagine that I drew that as a straight line, right? We know that the tangent of that angle is going to be 0.041 over 7. So find that angle, theta equals, right? I plug it in for this, right? You have the wavelength. We know that that first minimum happens at sine theta is lambda over d, okay? Yeah, solve for d. That's going to be the width of the slits. And when I did that, I got a number that's about 10 to the minus fourth meters, and that's correct, okay? So let's look at the next thing here, right? Then they say calculate the separation of the two slits, right? Well, in the whole scheme of things, right, that is, we're solving for this guy. So d sine theta is equal to n lambda, okay? D sine theta is equal to n lambda. We're trying to solve for this d. What is that, right? Okay. Now, I think that we are at point A, we are at 1, 2. I think that's right where the third brightest spot would be. So I think n is 3. Lambda is going to be 590 times 10 to the minus third, right? So plug that in, right? And then what is that angle? Well, that angle is the same angle that it was, right? That angle is, it's 4.1 centimeters, right? So that angle you're going to get from this theta is tan minus 1 of 0.041 over 7, right? Okay, so find that angle. It's like 0.3 roughly degrees, right? But use it in all of its precision, okay? And then solve for d, which is going to be on the order of 10 to the minus fourth meters, okay? All right, happy hunting.